Welcome to HackAtom HCMC into this the workshop on no-code NFT implementation using the interNFT standard. To give you guys a quick introduction, my name is Deepanshu from Persistence. I work as a CTO there and mainly uh, uh, look after the delivery of products and implementation. Uh, so today's workshop, we try to go through the modules and the interNFT standard that has been created uh, with a promise that there would be no coding required to implement an NFT marketplace out of this particular standard and the modules, except for a little bit of configurational code and, of course, a little bit of UI changes to a, a web project that is already integrated with these modules. So to kick off, here are a few resources that you might find useful for this workshop. The uh, markdown that I'm presenting is available at this link. If you would want to test um, integrations with the hosted chain with all of these modules that we are going to discuss. The REST endpoint is available here, and the RPC endpoint is available here. A demo of this application is present at demo.internft.org, and the interNFT specific standard specification is uh, specified in more details at internft.org endpoint. There's a GitHub also called GitHub/internft, where all the RFCs, the request for comments, and the standard specifications have been detailed in depth. So to kick off, what is interchain non-fungible token? Currently, we have multiple standards of NFTs, but majority of them are based out of Solidity smart contract interfaces. So we have interfaces like ERC 721, ERC 1155, ERC 994. So these interfaces help us define a standard way of implementing NFT so that other smart contracts can interact with them in a predefined way. But currently, we don't have any common implementation of NFTs at the native chain code level. For example, fungible tokens have implementations at, let's say, the smart contract level in the format of ERC20 tokens, and at the native chain code level with, let's say, the accounting model of sending and receiving token, or the UTXO model, like in Bitcoin's case. But to draw a parallel, there is no such implementation of NFTs at the native chain code level. So the interNFT standard tries to define a standard implementation for NFTs at a native chain code level, which at the same time is able to be applicable and transferable in the interchain universe without without any major caveats to limiting the functionality and the affordances of this particular implementation. Why a native interchain standard, and what are the challenges with it? Of course, if one tries to define a native standard, that implies that this particular implementation has to handle a bunch of different use cases. Smart contract can be modified, can be redeployed, etc., to suit a varied scope of use cases, but native chain code level implementation would not allow so. So either the inter-NFT interface should be such a format that every chain that wants to implement an NFT the use case should be easily able to extend this without having too many caveats that will limit the functionality of the NFT, or the native implementation itself should be vast enough that there is no further extension or implementation required, but one implementation it should be able to suit all. So that's a very tall order, and that is why the standard is implemented in a specific manner, which we will discuss going forward. So, to discuss the challenge, uh, the major challenges are there has to be one single token representative, a single identifier is able to identify NFT throughout the interchain world. For example, currently, if we look at the NFT identifiers, they're able to very well identify, let's say, for example, an ERC721 NFT ID and identifier. That identifier will be very well able to identify one NFT on that particular smart contract. But if we were to generalize that identifier to account for all the ERC721 implementation, it won't be able to extend further than that because there's no standard yet to define such identifiers. So the first standard is to define a standard that will uniquely be able to identify NFTs across the interchain world. So for this particular, just to peek ahead and discuss a little bit about how this particular problem is solved, there is a W3C standard which is called the DID, which are decentralized identifiers. We utilize interchain NFT standard utilizes this particular standard to define identifiers, interchain identifiers. The second biggest challenge is that each different NFT has a different mechanism for mutation logic for its metadata. In fact, majority of the NFTs do not even have a mutation logic, but once they do, each of them vary and have a different mechanism to implement metadata. So there must be a standard way of representing metadata of different kinds, strings, numbers, URIs, and B, there must be a standard interface for any NFT to be able to modify this metadata internally with the modification logic being extended by business logic through the implementation of this interface. Then we have the standard identifier that works interchain. It's same as the first point, except that it also includes the identifier to be able to identify NFTs across chains. So irrespective of where your, let's say, credential of, let's say, a driver's license was issued at, whether a chain A or chain B, there should be, the identifier should not cause a namespace clash between, even if these credentials were issued twice, there should not be a namespace clash. Moving on, we have the challenges around how to have a standard NFT representation and have a unified wallet for all NFTs. Again, currently, there is no one singular unified wallet where it can hold all the separate NFTs. Internally, the way NFT query works on, let's say, ERC721 smart contracts is that you have to go to all the smart contracts, implement the 721 interface and ask. But if your address holds NFTs for you, but if you look at the implementation that we have at Cosmos for tokens, where one wallet can hold tokens from any chain, one wallet can hold token issued through IBC on any chain. There is no such singular wallet for NFTs yet, so that's a big challenge. Other challenge is having one singular identity to different metadata and identity across chains. So, for example, one NFT might have a metadata field referencing the artist of the NFT. Since it's an interchain world, generally in the current scenario, we identify a person through their public addresses. But public addresses are very low-level cryptographic native of the chain, and every chain has different natives and mechanisms of representing these wallets. So, for assertion's case sake, for interchain world, if an NFT is referencing a person, how do we identify in the interchain world in a standard fashion that particular person or identity? And how do we difference the metadata across different chains? So there must be a differencing mechanism, kind of like URIs or URI and IRI internationalized URIs. So a standard around that. And the final challenge is on-chain and off-chain verifiability. Of course, any data that is present on-chain can be said to have be verified through all the validators and the chain logic that has been put on the chain. But in an interchain world, it's difficult for one to implement a verification of the state machine that is a different chain on another chain. So, for example, an IBC, we have verification, to and fro verification between the states of chain A and B that are connected with each other. But for example, if I wanted to connect NFT or reference an NFT that was issued on, let's say, Ethereum, so I will then have to implement a full-fledged like client verification at both the ends to be able to verify if the states were correctly represented or not. So, of course, in all cases, we don't want to do it. For example, if one wanted to represent that a particular credential in an NFT has been verified by a person or not, verified by an address or not. There are two ways to do it. First is we send a transaction and record that record in the state that this particular credential was verified by address A, and just store that information and not store the signature. Assume that the signature was stored in the transaction itself. The second way to do it would be to store the signature and the signing algorithm along with the credential. In the first mechanism, the chain that is referencing to this credential will have to know how to verify transactions on the other chain to verify if the verification was done or not. And to prove that the verification was done or not. But in the second mechanism, where we store the signature along with the credential, it does not matter if the transaction went through or not, as long as the chain has a mechanism to verify the signature that is stored along with the state, then there's no issues with interchain verification of metadata, be it on-chain or off-chain as well. So, yeah, these are the challenges. Now, how did we assimilate these challenges and implement the interNFT standard, the core characteristics of the interchain standard? Of course, to be very clear, this standard is still under development, is still being discussed. The RFCs are still open to comments. Majority of them have not been finalized. So yes, that's a disclaimer to be followed before we go into the implementation of this. So the core characteristics of the interNFT standard and the metadata is each NFT will be guaranteed a uniquely identifiable identifier that is ensured to not clash with any other identifier issued on any other chain. So, of course, for an NFT, one can as an identifier, one can place any string as an identifier for the NFT. There is no standard around it, but interNFT standard defines a standard around how to generate an identifier for an NFT. We will not get into it right now, but to give you a quick hint, it gets done through generating hash of all the immutable properties. So irrespective of like how many times you try to generate the same NFT, the identifier will come out the same. And yeah, one cannot issue NFTs with the same details twice, because it is assumed that if the immutable properties, immutable characteristics of an NFT are same, then that NFT in essence is the same, representing the same entity. The second is ownable. There must be a mechanism to own this particular NFT and also be able to transfer this NFT. The third is resolvable. And given the identifier of the NFT, I should be able to have a method to identify which particular entity or chain issued it and be able to go to an endpoint and query the details of this NFT. So it should be resolvable in an interchain universe. Fourth is decentralized, as in there should not be any central authority that is issuing, for example, the identifier for this NFT or issuing the mechanism for exchange, the transfers of this NFT, etc. All the transfers and generation logic should be fully decentralized and operationable without there being a central authority governing these particular simple mechanisms. For example, let's say if there were a central authority issuing driving licenses, then how would they identify each driving license? Well, the mechanism, majority of the central authorities issuing such credentials would utilize would be to generate a random number. And this random number would match to certain details only in their hidden off centralized database. And only this authority will be able to identify if the ID is authentic or not. So the ID generation part then becomes centralized. But in inter-NFT use case, of course, there could be no such central authority issuing the random number, generating random numbers to identify and then secretly storing what these numbers mean in the databases. So this process has to be decentralized. That's why there is a mechanism of hashing utilized to uniquely identify each NFT. Fifth is persistent, as in all the details of the NFTs, including the metadata associated with it, should be persistent. What that implies is even if a few nodes or even if a few components of the system go down, the NFT itself should be operationable irrespective and should continue to do so indefinitely in the future until it is not burnt off. So for example, we would have heard about a concept called dandy NFTs. So some of the NFT implementation, they offload the responsibility to store the metadata to a totally off-chain data source. Now, this data source is not as persistent as the blockchain itself. For example, Ethereum in this scenario, and this data source might go down or fault or lose its state or whatnot, causing the NFT to not have any metadata at all. These NFTs are called damning NFTs. So there should be a mechanism so that even if all of the metadata is not stored on chain, there should be a mechanism to have some verification methodology for this NFT, for the data, linked data, to be saved on a persistent storage. And as long as there are some entities that are storing this data, they should be able to share and be able to verify that this particular NFT data exists or not. Cryptographically verifiable. Going back to the last point, of course, all the metadata that is linked with this NFT does not necessarily have to live on the chain, but the proofs of the data metadata has to live on chain. So if I were to present you all the metadata linked with this NFT, you should be able to verify if the metadata is correct and has not been tampered with. And finally, we have stateful. Statefulness implies that NFT should not change state randomly. For example, let's say if we have a identity NFT. Now that let's say since we're sticking to the driver's license credential NFT, let's stick to it. So let's say there is a driver's license that has a field called name in it, and it has a field called date of birth in it. Now, should there be a transaction allowable that will allow you to change the date of birth of this particular credential? Because technically, this credential, this field is not modifiable. The date of birth should not be modifiable. But if a implementation is allowing you to change the state of the NFT in such fashions that is not stateful, that is not following a state machine, then in that scenario, that will not be considered stateful. So the NFTs implementation should have statefulness and should not allow for inconsistent state, like transactions to lead the NFT representation to be in inconsistent states. So yeah, these are the core characteristics of the interchain NFT standard and metadata standard. Quickly going through the salient features and the comparison with ERC 721 before we jump into the code. We will not be coding, but we will be looking at some code for sure. Okay. Yes, so some of the salient features here. The ownership representative and the metadata are separated out. So what that implies is each NFT, as we have identified, each NFT might have its separate metadata structure and different mutation logic for metadata. But what we have in common for all NFTs is the ownership representative, the ownership logic. The ownership logic flows through a certain certain mechanism that is stateful. For example, like the same way your ERC20 tokens will flow, or same way your native chain tokens would flow. The ownership of the NFTs we can assert will flow in the same way, unless someone has not signed a transaction to send an NFT from their wallet to someone else's. The NFT should not change ownership. So for the interNFT implementation, we have segregated out these two concerns. What this allows us to do is have the ownership representative flow through to other things, while the metadata representation can stay on the implementing chain. This implementing chain might have its own complex business logic and application logic to modify and maintain this metadata, but the ownership logic has been abstracted away and can be operationalized by other chain as well, and the invariants can be maintained by other chains as well. So there is this segregation. Singular. Another feature we have is called singular representation and instantiation. The DID standard that we follow allows us to create identifiers for this NFTs that do not cause any clashes in the namespaces. Even if a chain were to ape and would try to create an NFT which is a replica of this particular NFT, the ID generation logic would assert that the chain ID be included along with it, which would differentiate these two NFTs, never allowing two NFTs same instantiation of the NFT to exist twice. Now, the authenticity of this NFT, which has the same data, which has been issued twice by two different chains, can then be asserted through other mechanisms like timestamp at which one was enabled, or through the public key of the issuer and claiming the ownership of this key by the actual issuer of the NFT, etc. Single wallet implementation. As we discussed in the first point, the ownership representation is one. There's only one mechanism to represent ownership. So what that allows for us to do is have all the NFTs issued by different applications and different chains, and having different implementations to just have one singular representation of the ownership token, and that allows us to have just one wallet in which all the different kinds of NFTs can sit. So yeah, one universal wallet for all different NFTs. Fourth is implementation of accessibility, of course, since the metadata part, the metadata interfaces, uh, uh, although they do exert some restrictions as to what kind of metadata an NFT could hold, and the state change, that possible state change that this metadata could have. But the overall logic is totally extensible by any chain application, so which allows for implementation flexibilities and as to how the state change could happen. Fifth is the reduced load on interchain protocol. Since the ownership transfer and the metadata are segregated, that implies that whenever one is transferring the NFT representative from chain A to chain B, they don't necessarily have to transfer the metadata of the NFT along with it to make the NFT operationable on another chain. Because at the end of the day, even if the metadata were to be transferred, there is no way to make sure that the other chain knows how to operationalize the state change transactions on for this particular NFT on their chain. So the interchain protocol has reduced data payload to be transferred to other chain when there is a ownership transfer happening, and B, the state transition logic could rest safely in the native chain on which it was initially implemented without there being any challenges around how to ensure that the foreign chain is following the same rule set to mutate the data, or is not erroneously mutating data based on some foreign logic. Sixth is commoditization. All these NFTs have a classification ID associated to them, which is extensible. Which one can inherit. What that allows is, instead of referencing these NFTs in your wallet with the exact identifier, one can also refer to them with their high-level class identifier as well. So, for example, instead of saying that I want to transfer over my Toyota Prius with the license plate number 6677, you can say I want to transfer all the Toyota Priuses in my wallet, or can also say that I want to transfer all cars in my wallet, or 10 cars in my wallet for X amount of money, and so on and so forth. Trusted minted mutation, burn logic, and interoperability with private chains. Since the metadata execution logic and the metadata mutation logic sits at the native chain from which it was issued, and can operate independently from the ownership transfer logic. This allows for the trusted chain to continue operation of the metadata mutation logic on their chain, while the ownership transfer logic can flow to any public chain without any security risks. What this also allows is interoperability with private chains, chains that might not expose their state to public chains, but can create transactions to like transfer over the ownership representation to public chain while retaining the metadata logic and metadata state in their private chains. And finally, we have native implementation interoperability. Of course, since this standard is implemented on the native chain code level, this allows for, and not on the smart contract level, this allows for interoperability utilizing the interchain and protocols as well, for example, IBC or ICMP, etc. Yeah. Now going on to the comparison between ERC 721, how does implementing an NFT utilizing the ERC 721 interface differ from implementing an NFT utilizing the interchain standard? For ERC 721 interface, the wallet exists works in a different mechanism, as in one has to query the smart contract with your address to check if that smart contract holds any NFT for you or not. So that would imply that there could be, let's say, thousands, if not hundreds, of smart contracts that someone might have.
Um, Hello, am I audible now? Okay, okay. Yeah, sorry for the interruption. My audio device changed battery on my headphones died. Okay, carrying on. Comparing rewinding a little bit, rewinding for like the last 20 seconds. Comparing the internet standard with the ERC 721 standard implementation. What would vary if you were to implement your NFT with the ERC 721 interface rather than the interNFT interfaces? The first is, of course, the NFT address resolution. The way the smart contract based implementation works is for wallet. They work is one will have to query the smart contracts with implementing the NFTs with the addresses to check if the NFT, if that smart contracts hold any NFTs for you or not. Now there could be hundreds, if not thousands, of such smart contracts, and it would be your responsibility to go, or it could be the wallet's responsibility to go to each of these smart contracts and check if they hold any NFTs for you or not. And that could sometimes lead to like discovery issues, etc. But the way internet NFT wallets work is that there is just one singular wallet associated with each identity or with each address, implying that all the different NFTs that you might have from all the different implementation NFT issuers will just sit in one wallet. There is no discovery issues. If someone has to send NFT to you, they just send it to a wallet and it just pops up immediately, rather than you having to query a XYZ smart contract. And also on top, all the NFTs that have been issued throughout the inter NFT universe, interchain universe, can just sit and be represented in one wallet. Uh, so yeah, sorry, I messed up. I went with the point two first. The first point is NFT address resolution. So each NFT, of course, in the ERC 721 implementation may or may not have a standardized mechanism, standardized naming mechanism to identify that NFT, which implies that each the ERC 721 NFT would have its own mechanism to identify NFTs. And it would be difficult to check if your particular NFT with the identifier that you have received exists with let's say, other smart contracts have been issued by other smart contracts or not. So, for example, there could be one smart contract that is issuing a set of rare collectibles, while other smart contracts may decide to do so, slightly changing the identifier, and there being no way of discovery if the same metadata and identifier are being utilized by the other smart contract or not. With interNFT, uh, there is a singular mechanism for creating identity, a standardized mechanism for creating identifiers for the NFT, which ensures there is no clash on the same chain. And of course, one cannot ensure that the same NFT cannot be issued by other chains with the same metadata, but what can be ensured is the identifiers will not clash. So yeah, the third main difference is the smart contract execution overhead. Of course, one might have seen a lot of comparisons and concerns around NFTs consuming a lot of power for issuance and for transfers, etc. Per like of course, it's all amortized over each transaction. It does not mean one transaction is costing that much energy. It's amortized for the transaction, but still implementing NFTs over smart contracts undeniably brings in a layer of extra execution logic, increasing the increasing the gas spent and the time spent on processing that particular transactions, and this number of transactions that can be processed in one block, if not the energy consumed. uh, Implementing NFTs at the native chain code level not only increases and enhances the number of transactions that can be processed, but also reduces the energy consumption. And since we are talking about Cosmos, of course, Cosmos chains generally consume a fraction of the energy that like one Ethereum chain might consume. So we've got that efficiency factor at our end also. And third is interchain. Fourth is interchain operability. So as many might put it, the comparison between Ethereum and interchain and an interchain uh, interconnected interchain ecosystem is such that one might compare Ethereum with all its smart contracts like people living in apartments in New York. There is hyper connectivity, there is very ease of access, but what you can do with that space is very limited because the apartments are cramped and it's very expensive. Of course, the transaction fee is very high. On the other hand, one can compare interchain connected chains as like suburban areas that are connected by highways to each other. There's a lot of space. It's cheap to like build huge houses and at the same time be connected by to other small suburban areas as well. So the interchain standard, it's natively interoperable with other chains and does not require any permission bridges to transfer over the ownership representatives of the NFTs to other chain. While on the other hand, for Ethereum smart contract ERC-721 based or Ethereum based NFTs, one can like transfer the NFT to other smart contracts that are on chain, that can be referenced on chain. But there is no simple mechanism of transferring these NFTs over to other chains in a standard format. Either one has to implement a permission bridge that is able to do so, and that is very specific to that particular smart contract. It is not generalizable across all smart contracts. Or, of course, utilize like burn mechanism or wrap mechanism to transfer over these NFT representatives. So these are the four major ways in which the ERC 721 implementation differs from interNFT implementation. Of course, there are many more points. The points around how the metadata is managed, points around the mechanisms in which the state chains are enforced across mutable and immutable components. But we will discuss those as we go through the project, this workshop. All right, so we are the setup stage. Of course, I have set up my environment already. If you'd want to set up your environment, you can. If you're watching this over YouTube stream, then maybe you can pause this stream right now and try setting up your environment, and can unpause later. I'm not going to spend much time on the setup, but give you a brief insight into why we are making this setup. So yeah, of course, for ease of access and for ease of replicability of the commands that I will be sending, would recommend that we create a workshop folder in the user directory, in your user directory, so that like all the commands are same between my system and yours. And then would ask you to clone the Cosmos SDK. There are a few modules that we will be importing from the Cosmos SDK to operationalize our NFT implementation. And also would recommend to import the SDK at version 0.39.x. It's not 0. We can import any 0.39 subversion, patch version of the version 0.39, does not matter. Why we're using 39 is because it is before the Stargate update, and it's a long-term supported version. Yeah, it's easier to work with, and all the other modules that we'll be working with are also compatible with the particular version of the SDK. Other project that we'll have to import is the persistence SDK. Now, this particular project has all the has a sample implementation of the interNFT standard. So this is one flavor of how interNFTs could be implemented, but one can interpret the RFCs into multiple different ways and have multiple different implementations. But for this workshop, we're gonna stick to this particular implementation. And then we have the asset mantle project. So this is a configuration project. It does not hold any major logic. It just imports and configures, makes some configurations to make the modules run. That's it. And then, yeah, of course, boot up your favorite IDE, and we will be ready to go. Before getting into how to import and configure, of course, this is a no code workshop. We would not get into like coding per se, but we will have to get into some configuration to set up a project. So yeah, let's then quickly talk about the modules that we would be utilizing from the Cosmos SDK, which would be the bank, auth, and the params module. And let's quickly talk about the modules we would be importing from the persistence SDK, which is the identity, assets, splits, and orders module. Quickly checking if I'm still connected. Yeah, looks like I'm connected. Okay. So yeah, switching over to the IDE to look at the directory structure and how modules in Cosmos SDK are implemented and how to import this into your project. To stress on this point again, one does not have to import any of these modules. One can implement all of these modules on their own. But since these are already in production modules, and since this is a no-code workshop, we can choose directly to import these modules rather than implementing once. So yeah, let's look at the directory structure for Cosmos SDK and look at the bank, auth, and params module. Okay. Yeah. So yeah, the SDK is imported into my dependencies. So I'm gonna open it from my dependencies view. I got Cosmos SDK right here. We can see the version that I'm importing it at is 0.39.1 with the commit hash 9D00F. So yeah, it's up to you whichever patch version you would offer of the SDK that you'd want to import into your project, as long as it's the minor version is still 39 and major version is still 0. So yeah, looking at the Cosmos SDK directory structure, in Cosmos SDK, all the modules are organized into the package X. So in this package, you'll find all the different modules that are importable out of the SDK. The one that we'll be looking at is called the bank module. Now, the bank module is the one that is responsible for maintaining the wallets, maintaining the tokens, etc. So yeah, if you look at the spec has the documentation around what the state and what the state of this particular module is, as in like the key value stored for this particular module, what data is it storing, and keepers is like controllers, as in like how this data in the key value store or the model is being modified. Messages are, one may say, messages are like it requests to this modules to change the data in the or change the models in this particular module. Events are like the events are WebSocket events that are emitted by this module when certain things happen. So one can subscribe to these events, and like the client could change states or produce notifications, etc. Parameters. So since this is a blockchain project, it cannot carry a configuration file and change application based on configuration. Rather, it carries parameters. Now these parameters, how will these parameters change? Because if the parameter has to be changed, then there's no configuration file which you can change and restart your node and it will be changed, because every node has to have the same configuration. So how it changes is through governance proposal. So there's a gov module which have access to the KV store, the parameters KV store for this particular module, or rather, to put it in a better wording, the gov module maintains a parameter set for this particular module, and one can produce proposals to modify parameters in this module. So this particular module, the bank module, carries only one configuration, which is send enabled, which implies that if a send and receive of tokens are enabled, the transactions is enabled or not. So I guess 90% of what we require from this module we can directly make from this particular spec documentation. If not, then of course we can directly look at the code. You have the module.co, which defines the which implements the app module basic interface, and actually these three interfaces, and implements all the necessary methods that are required for a module to be called a module. Other than that, the endpoints one can look at through the client package. The client package has got the CLI interface. So like this specifies the command line methods that can be called on this particular module. So for example, here we have the sendtx, which would be invoked by this particular key term, which is send, and the whole like command would look something like node space tx, which is the root command for transactions, space module name, which is auth, space send. So that way one can read this particular transaction and invoke one of the, as we can put it, APIs, but rather actually transactions exposed by this particular module. And similarly, we have the REST endpoint as well, so we can call the same transaction through the REST endpoint as well. In this scenario, it will look something like bank accounts transfer, and there would be a query also to check the contents of this particular module. So yeah, that's about bank module. Bank module basically allows for transfers of tokens. So there's one transaction exposed by it, which is a send transaction. Then, as discussed, this particular module has certain parameters. So we have got the param modules, which contains the the sub KB store, for which maintains the sub KB store for parameters for bank modules. So, for example, we saw that bank module has a parameter called send enable. So parameters module is the one that is maintaining this particular variable, and gob module is the one that is exposing a methodology to change that parameter. Of course, that is important because any application, NFT application that you might be implementing, you will have to include certain configurations for it, and the params module and the gob module mechanism of how to modify these params would come in handy in that scenario. So yeah, bank auth params for the three modules. Auth module is just responsible for verifying transactions and sending them. If we look at the spec, we have the state. The state contains the accounts, which is a linkage between the address to the account. Now getting into the persistent SDK module. Before that, quickly checking if I'm connected. Yeah, looks like I'm still connected. Carrying on. The persistence SDK directory structure is a little bit different, in that the modules are maintained under the modules package rather than the X package. But other than that, it's very similarly structured. We have so this particular module, like the internal package, anything that is declared inside internal package cannot be exported outwards. So this preserves like permissioning of certain like keepers, or like in MVC terminology, the controllers, so that like other modules are not able to modify the state of this particular module without having the correct permissions to do so. So internal module has everything that is not to be exposed, and only this module has the rights to modify. The auxiliary package are like services that are exposed by this particular modules to other modules. Now there is still verification as to if that module is able to utilize this auxiliaries or not. But yes, these are like what is exportable to other packages. So let's have a look at the assets module. So assets module has got a prototype. With this prototype defines the name of the module, the auxiliaries declared by the module, the genesis state of the module. Mapper is kind of like your in MVC model structure, like ORM, object relation mapper. So here we instead of copying it ORM, we just call it mapper, which just links the KB store bytes to and converts it into object. We'll get into how that is happening later on. We have the prototype as parameters. So these define all the different parameters that this particular module is exposing. And we have the queries. Again, the queries exposed by this module. Simulator, the simulator package has logic on how to generate random states for this particular module, so that we can quickly run simulations on this blockchain rather than waiting for, like, for example, like even if you wanted to utilize some black box testing mechanisms for load testing, etc., there is a slight delay in the processing of the transactions and the data to be available. So since each block is being processed at around 6 seconds. So if you do not want to wait for that long to have your data be modified for you to check if it's in the correct state, you can just implement the simulator, which will quickly implement your random state and quickly implement random state changes. So you are able to verify if the invariants for this particular package are held or not. Then we have the transactions prototype, which implements all the different transactions that this particular module is exposing. So all of these are being declared and implemented in these packages, the transactions and simulators, queries, parameters, mapper, and yeah, auxiliaries right here. So the asset modules in this scenario is the one that is mapping the asset to the identifier. So this is the object that is being maintained by this particular module. This is the asset module, which basically is implementation of the interNFT interface. So this is one example. This is one base implementation of interNFT interface. This has a member's ID, which is the identifier for this particular asset. It has the immutable and mutable trait sets also. So more about that later. Then we have the identities module. So identities module has the same directory structure, and instead of storing an asset, it stores an identity. So identity has internally the data set is exactly the same, member set is exactly the same. It has an identity ID, it has mutables and immutables. Then we have the splits. So splits is actually the ownership representation of these NFTs. We call it splits because this NFTs are allowed to have fractional ownership as well as a derived ownership. So splits modules represent the ownership representative of each NFTs, and how many splits or fractions of the NFTs is owned by one particular wallet. So the object looks something like this, which is ID, which is the NFT identifier or the asset identifier, and the value, which is SDK type DEC, which is a decimal. So for example, if it's an NFT which just one unique representative, then this particular field will be populated with the smallest DEC, so that the mathematical operations like addition, subtraction, or division, etc., would just result in the value coming back to smallest DEC itself, and there being no possibility of fractional transfer of this particular NFT. For NFT that can be fractionalized, one can set the value of this NFT through this transaction called renumerate. Transaction, set the value for this NFT, and then it will populate more splits for this particular NFT. Then finally we have the orders module. So orders module is a singular module that implements a mechanism for people to, in a decentralized fashion, exchange their splits or ownership representatives. It can be called a DEX, a decentralized exchange. So this exchange has multiple mechanisms for exchange. So for example, there is immediate, the structure again is very similar to identities and an asset, which is each order will have an identifier. The identifier is a composite of the two assets to be exchanged plus the fraction to be exchanged, which is the exchange rate. So we can see how the ID is getting generated under the key package. So for example, yeah. So this is how an RE is looking like, which carries the classification ID, maker, taker, ownable ID, rate, creation ID, and maker ID and hash ID. So this is how the ID for an order is generated. Although we don't have to worry about that. That all of that is internally taken care by the module itself. It interprets these IDs from the request that is sent to the module. So the order has members ID, mutables and immutables, again like orders and assets. So yeah, these are the four modules that we have. So how do we next we get into how to import these modules into your project. Of course, I'm assuming that you already know how to import the Cosmos SDK modules. The Cosmos, but just to give you a quick insight, to import Cosmos SDK modules, one has to implement an application. So for example, in this case, let's look at a base implementation of an application. So to import Cosmos SDK modules, one can take reference of this base implementation. So we have the initialize function, and it is importing all of these different modules. For example, staking, auth, WASM, Gov. This particular application is importing all of these. Now there are more configurations below. For example, accounts keeper is being initialized here, a bank keeper is being initialized here. So there is nothing much to do here. It's all configuration. We can just copy paste these and we'll still have our app running. Similarly, to import the persistent SDK module, in the first step would be to go to your go.mod and add the dependency persistent SDK. One can import it at version 0.1, which is a last stably tested version, which is supported also currently. And so we go to the go mod, and okay, so this is the persistent SDK, so mod itself. So we will go to the asset mantle project. Okay. After that, after importing this particular module, we will add the keys, add the KB store key for this particular module, whatever module that you have imported, to the keys array of the application. So that will look something like this. Into the application, we have the keys. So if you look at the structure, we have the application object struct has a key member. So this key contains all the KB store keys for each module. So we'll have to get our module keys added to this particular set. So for example, if you want to import the assets module from SDK, you do so. You create a new KB store keys, call the new KB store keys variadic function, and just add the name of the module as the KB store key for this particular module. Then we have the initialized module. So for example, let's pick up a module from the SDK. Let's pick up assets module. So here's the assets module. So as we saw here, we have in the modules package, in the prototype, we have defined the prototype itself for this module. Now this prototype is not complete, it's not usable still. It will become usable once we initialize it. So in the application definition, we initialize this module. So we call the prototype.initialize method. Now this takes the KB store key that was generated for this application, which we declared above, and it takes a set of different auxiliaries from other modules to operationalize transactions. So for example, it takes auxiliary from, it takes conform auxiliary from classification module, it takes define auxiliary from classification module, it takes deputize auxiliary from maintainer module, and so on and so forth. And after initializing, of course, if we want to, and so this is an optional step, there's not a necessary step, but if you want to enable WASM smart contracts on your module, and there is a very easy way of doing so. in the WASM keeper, we just include the module object. This module object already implements the methods in the interface required by the WASM module to be able to include it in the set of modules supported by the WASM module. So just pass on the module object inside this constructor, and we'll be good to go. That's all that is required to enable WASM utility with your module. Quickly checking again if my connection is live. Yeah, looks like my connection is live. And after this optional step, we have to include the our module inside the module manager. So how that would look like is, and what that means is, so for example, if we look at the base app implementation, we will see that each application structure has got a module manager inside it. Now, this module manager is basically a set of interfaces, manager interfaces. It's a set of manager interfaces which the application iterates over to initialize a bunch of stuff and to, for example, initialize the KB store, the Genesis state, etc. So it's a basic interface that each module has to expose to be able to be included in the application. So we need to get our module included inside our basic module manager, and for that we do this. We create a new we have a new constructor, we have a new manager constructor from the module package, SDK module package, and we import the Cosmos SDK modules like so, and we include the persistence SDK modules like so. Just add the initialized module object, and that's enough to get included into the module manager, because this object already implements all the methods that are required from a module interface. And finally, we have finally actually, for the application, we just have to define the order in which the Genesis should be created. So this is a configuration on module manager itself. So set Genesis module manager dot set Genesis order. So this instructs the module managers to go in a certain order while initializing these modules inside the application. So of course, all the Cosmos modules are the OG modules on which other modules depends, like persistence SDK module depends on. So they go on first, and in general in this particular order as is. And then we have the SDK module. Now the SDK module also will go inside the application in this particular order itself. We don't have to change this order. If we change this order, that might lead to certain misconfigurations, etc. And finally, we have the simulation manager. Again, this is not a compulsory step. Not all applications have to have a simulation manager, but you can include yours. So to include your modules, SDK modules inside the simulation manager, it's very easy. Just call the prototype object, and you should be good to go inside the constructor new simulation manager. As you can see, we are not utilizing this this piece of code at all. It's just there for the sake of it. And that's it. That's how you integrate one module into your application. For ease of use, there is one interface that is already exposed by the persistence SDK, which is this application interface. So this includes all the interfaces that are by default required to run application on the Tendermint consensus engine. So to run an application on the Tendermint core, one has to have at least this interface implemented, which is the APCI application interface. On top, we have implemented more ease of use methods on top. So like one can utilize this or can directly make their own application also, like and refer to the Gaia project to do so. Now for each application interface, we have a base implementation also. Now this base implementation is one simple implementation of how to do create your own application. Now this particular base implementation has included all the modules from Persistence SDK and Cosmos SDK. So this is a sample configuration that is including all the modules inside one application. But you may not necessarily require to include all these modules inside your application. Maybe you don't require the orders module, you don't require DEX, maybe you don't require slashing, or maybe you don't require governance in your application. So you may safely exclude this from your application and implement your own application. If not, can directly also import the base application inside your project. Import it directly from the Persistence SDK and you make your own application out of it. Run the whole chain with all the modules and then choose at your end which transactions to enable and which not to enable. So yeah, that's how to include the modules inside your application. Again, we have not coded yet per se. We are just configuring, and if even if not to configure, can directly import this application, import this implementation inside your application, and you should be good to go. There is only one method that needs to be called, which is the new application method. In fact, and don't have to import any of this. Just have to call this method and configure your very basic stuff like the name, or basic manager, enable WASM, enable modules, account permissions, and total token receive account modules permission. So these are again configurations that we will shortly see how to configure. Okay. So yeah, going quickly through how to interface with the Persistence SDK module that you might have already included in your application. It's very simple. So whatever is the binary name that you're giving to your application, followed by, if it's a TX, then or a query, then query, if you're going through CLI, then the module name, and then the transaction or query name. If you utilize this particular regular expression you can create any transactions, CLI transactions for your for this module that is already included without referring to the code at all. Although for each particular exposed transaction, one can directly go to the transactions package for that particular module and pick up the transaction. For example, let's just take the mint transaction. The mint transaction is the one that mints NFTs, and just look at the request. So this is a very basic request. It does not include any complex data types that cannot be Marshall and Marshall like a normal JSON. And this also includes the validation string, also the regular expression that this particular field has to match. So as long as you're able to create this object, you can either send this object directly through the REST endpoint from the REST endpoint, which the REST endpoint will convert it to JSON object from, or you can send it through CLI as well. But yeah, the names remain the same, and if one has to, in the flag name remain the same as the parameter names here, the member names here. No differentiation, and the data type also remains same. For the base request, of course, the base request would be parameters that are to be included by default in any of your Cosmos based requests. For example, node ID, chain ID, etc. So let's quickly have a look inside this too. So yeah, from to chain ID, account sequence number, which is auto-populated actually. If it's a simulation, if it's generate only fees, gas price, etc. We'll have a quick look at how to generate a basic CLI request also. And other way to interface with your module, again, quickly checking if I'm connected. Okay. Yeah. Anyways, the REST endpoint. We can also interface with this particular module through REST endpoint. A REST endpoint will follow this regular expression. You have your host IP address, you have your port, or you can have your host name and a port, and then followed by XPRT to refer to any XPRT module, then the persistence module, and then the persistent module name, followed by if it's either a transaction or a query. If it's a transaction, then it will become a post request, and you'll have to fill in the post form fields. So those post form fields would be exactly equivalent to this particular object, with the JSON field name being these and the types being these. All right. So yeah, that's how you import and interface with any of these SDK modules. Now we have got little time left, so let's quickly get into the setup of the asset mantle project. So this asset mantle project is a pre-configured project which has all the different modules already pre-configured. So again, I'm not going to get into the setup. The way to get this project is to clone this, and there are convenient scripts that are put inside this project, when the setup, startup, and shutdown script. Just cloning the project and just running these 3 commands should be enough for you to set up a chain, to run a chain, and to shut down a chain. Moving on, now this is the part where we define how we can create an NFT. We can configure and create an NFT without coding at all. So I'm going to give a little bit of a pause here, and so that everyone is able to like assimilate this particular step if you're looking through the video. Okay. Yeah. So as discussed over the last few sections about how to import, how to create an application, we can forget about all of that. And if for the hackathon we have to create a very, very simple NFT implementation, then it would go something like this. We check out the asset mantle project, we do run the setup script, and we run the startup script. Now what this will do is will set up a very basic Genesis configuration for your chain, and it will start a chain for you. Starting a chain would imply that all the RPC and the REST endpoints have now been enabled, which implies that you can now start interacting with this particular chain. So how would you interact with this chain to create your own NFT with no code? So first would be to define an identity. Identity is like a wallet but with metadata. So one can think of like your account generally just have your address in it, and that address is non-changeable. Of course, if your wallet has 100 token, and that's linked to your address, the public address. And if that you lose access to the private keys for the public address, then you lose your wallet as well. So how identities work is a little different. You can think of it as a account that is also holding a set of other metadata alongside with it. For this particular use case, we're not going to define a complex identity, and we're not going to rotate the keys, etc. inside it. Here, we are just going to use the nub identity. So as its name suggests, it's just the most basic format of identity. One can think of it like a username based login. So here, one defines the nub ID, which is which one can think of as a username or unique string identifying you. So for example, I've specified it as Deepanshu TR in this scenario. If that the username is already taken, your transaction will get rejected. If not, then you will have your own nub identity with the authentication set to your from address. So whatever from address you have sent will become the key linked with it, and later on you can change the keys associated with this particular nub ID. We don't have to worry about that much right now. So yeah, create your identity first, and then yeah, we can quickly query the identity as well. So the return, okay, yeah, my mistake, refresh the page. To query the identity, whatever is your binary name followed by the query keyword, identities and identities, specify chain ID, and as a result of the last transaction, you would have received a identity ID, and this would be your new identity ID. You can query it to see if it has been defined or not. So once we have our identity sorted, which is the wallet, kind of like the wallet that is sorted, we have created one for ourselves. The next step would be to define a structure for your NFTs. So interNFT basically has 4 different kinds of metadata associated with it, which we call traits. The first is immutable meta trait. So immutable meta trait implies any trait or property associated with an NFT that is immutable. That is, any state change transaction is not going to lead to the change of this particular metadata. And B is meta. Meta implies that that the data is stored on chain. Of course, this is a heavily gassed transaction if you want to store all the metadata on chain. But if you wanted to do so, there's an option for it. If you pick your immutable to not have metadata on chain, then you can send it under immutable traits. So what this is gonna do is the client is gonna convert all this metadata into hash and just send hash, and the module is just gonna store the hash of the metadata, so that in future, whenever you query the metadata from whatever centralized authority or peer-to-peer mechanism you have of sharing this metadata, one can verify if the metadata is the same and has not been mutated. Then we have the mutable metadata, as in any property fields that can be mutated in future for this particular type of NFTs, but is also present on chain. And we have the mutable traits. So how this will look like would be how the trait would be defined, property would be defined, would follow the regular expression of this. First would go the trait name. So for example, in this case, B is the trait name, semicolon, the metadata type. So right now the supported types are string, decimal, height, and ID, and they will be represented by S, T, H, or I. If we are going through CLI, that is. Of course, we have to stick to this convention when mentioning this in CLI. And followed by a pipe and followed by the default value. You can leave the default value empty, but will mint your NFT without any default value. But if the default value is set, then any NFT that will be minted would carry this default value along with it. If it is immutable, that default value will never be able to change also. So by sending this transaction TX define, assets define, you would have created one classification, one new type of NFT for yourself. After that, we would want to instantiate this NFT that we have just defined. So the result of this transaction would be a classification ID. So in this case, the classification ID for the properties that we have defined would come something like this. So we specify the classification ID, we specify the from and to ID. From ID will be the issuer. Whoever has defined the classification by default becomes the maintainer or the issuer of this NFT. Only that person is able to issue that NFT from that point on. So the from ID you specify as your identity and also should be the issuer of this classification. To ID is the person that you want to issue this NFT to, and you specify the classification. And then all the specific details of the properties you can fill. If it's empty, you can fill the property details in, and that's it. That's how you would have minted your own NFT with a specific classification. So what flexibility this allows us to have is, a, we can define NFTs which will have immutable traits, as in, let's say, we were discussing the driving license. So we can have the driving license that has a date of birth which is an immutable, which may never be changed, but it may also have a mutable trait, like the address of the person, which one can change. Also have different structures for this NFT. You can store string, decimals, height, or ID inside this NFT. On top, this implementation also allows you to store the metadata on chain and directly query it from chain. For example, if one is creating an art NFT, then can store the URI to the art in the meta field and directly expose this meta field on chain, so any prospect buyers are able to query and are able to buy this NFT. Also, you can hide this. For example, let's say there is a bid that you're creating, NFT for a bid you are creating, or an NFT for your card you are creating. You don't want your car's let's say price or value to be exposed, or the registration number to be exposed, so you would just store it as a non-meta trait. Now, what if you want to convert a meta to non-meta to meta trait? There is a transaction called the exposed transaction. This exposed transaction is gonna expose the property on chain. Then we have the mutate transaction, which works like so, and we have the send and burn transaction as well. Okay, I think we are in the final 4 minutes of this workshop. We would have discussed how to build your own asset module, extend the interNFT interface, and build a module that has its own custom modification logic. We would have discussed the bird's eye architecture, how this implementation is working, and the sequence diagram, and documents module, etc. So yeah, there would have been a lot to discuss, but I think we are at the end of this call. So I would, in that scenario, point you towards this URI. I'm going to make sure that this URI do not change. You can reference this for the hackathon, and reference this documentation to build your own implementation, either directly importing the application and running it, or creating and extending the interNFT interface and creating your own modules for this hackathon. Yep, switching over to the questions now, if there are any. I'm going to stop sharing my screen. Okay.
Okay, Deepanshu. I think in the interest of time, maybe we would not be able to take answers for now. So we would direct any questions to you by email after this. Would that be okay?
Right. Yeah.
Yes.
That would make sense. I don't think that we would be able to answer many questions in two minutes anyways.
Okay.
Would be looking forward to any questions. And yeah, my contact details is, of course, Deepanshu at persistence.one. So would be happy to answer any questions relating to this workshop, or to the module, or building an SDK application yourself. Thank you, guys.
Okay, thank you very much, Deepanshu. We will definitely stay in touch. And thank you very much again for spending time with us.
Thank you. Thank you, Nicole.
Thank you.
Happy hackathon to all the participants. Bye.
Okay. Okay. So hi, everyone. We have some announcements before ending this session. I'm going to do some Vietnamese translation following this, because we also have quite a few participants from Vietnam. Vậy thì xin chào các bạn. Mình sẽ có một số những cái thông báo dành cho các bạn thí sinh trong chương trình HackAtom ngày hôm nay. Thì mình sẽ có dịch và nói giữa tiếng Anh và tiếng Việt để các bạn có thể tham khảo. So number one is that we've already scheduled 3 pre-training, pre-hackathon training and a few other training sessions after the hackathon starts. So please join in please add in the Google Calendar that is sent to your email to your calendar so that you can follow all of the training sessions. Also, we have scheduled mentoring slots with our mentors almost on a daily basis. So please make the most out of the mentoring session where you can directly speak and work with the mentors to fine-tune your projects. Thì các bạn ơi, mình có gửi một cái đường link về cái Google Calendar, thì các bạn vui lòng add vào cái lịch của mình á, để mình có thể thường xuyên theo dõi những cái lịch đào tạo sắp tới của chương trình, cũng như là có thể tham gia những cái phiên mentoring với các cái mentor của chúng ta. Thì hiện nay ban tổ chức đã sắp xếp để gần như mỗi một ngày đều có ít nhất là khoảng 2 tới 3 mentor có thể tham gia và trao đổi với các bạn. Thế nên là các bạn hãy vui lòng là chúng ta có thể là tận dụng tối đa cơ hội này để có thể làm việc với các mentor nha. Thì thời gian dự kiến thông thường sẽ là từ 8 giờ đến 10 giờ tối hàng ngày giờ Việt Nam để các bạn có thể tiện theo dõi. So for number 2, for the second announcement, we would like you to join the Cosmos Discord channel to interact with the community and also with our mentors. And please fill in the form. Please use Discord as well, or fill in our matching members form to find extra members for your team. So at the moment, you can find up to 5 members for your team. So yeah, please contact us in case you cannot find any mentors right before the hackathon, so we can provide extra support. Các bạn vui lòng tham gia những cái kênh Discord của Cosmos để có thể tương tác với cộng đồng cũng như là các mentor của chúng ta, và ngoài ra là có thể đăng những thông tin tuyển thành viên của chúng ta vào đó. Ban tổ chức cũng có tạo một cái file Google Spreadsheet để các bạn có thể điền thông tin của các thành viên các bạn muốn tìm kiếm. Thì các bạn vui lòng là chúng ta sẽ tích cực tìm kiếm để có thể là mỗi một đội có tối đa là 5 thành viên, thì chúng ta có thể tìm những thành viên mà có thể bổ trợ cho đội thi của mình trước ngày hackathon diễn ra. Còn nếu như các bạn không tìm được thành viên thì vui lòng liên hệ ban tổ chức để chúng tôi có thể hỗ trợ thêm. So the last one is that our second training would happen on the 15th of June with the topic Zero to App with Terra. So we would have William Chen, the leader of the developer community lead from Terra, to speak with us about, contracting, about dev environment to web to mobile front end, and how to connect your applications on mobile through Terra Wallet Connect. So you would be able to go through, he would walk you through the basic development and how to build a large-scale DApp Terra using the basic contracts. Thì tiếp theo chúng ta sẽ có cái buổi training vào ngày 15 tháng 6 từ 20 giờ đến 21 giờ 30 giờ Việt Nam với chủ đề là Zero to App với Terra, và được trình bày bởi William Chen, là người phụ trách cộng đồng lập trình viên của Terra. Thì các bạn hãy vui lòng tham gia phiên đào tạo này để có thể biết cách làm thế nào mà chúng ta có thể đi qua những cái ý tưởng contract, và làm cách nào để có thể dev những cái môi trường web rồi mobile frontend, có thể connect cái app của các bạn qua wallet với tính năng của Terra Wallet Connect, và có thể được nhìn thấy và có thể xem cái quy trình làm cách nào build một cái large scale, một cái DApp quy mô lớn với Terra, và sử dụng những cái contract rất là cơ bản. Vậy thì chúng tôi cũng rất cảm ơn các bạn ngày hôm nay đã tham dự buổi training ngày hôm nay, và video YouTube này sẽ được các bạn có thể dùng để xem lại. Nếu như các bạn có những điểm gì thắc mắc, và vui lòng liên lạc với với diễn giả của chúng ta tại địa chỉ là Deepanshu@persistence.one. Nếu như các bạn có bất kỳ câu hỏi gì về các nội dung mà anh Deepanshu trình bày. Xin cảm ơn các bạn đã tham gia buổi training ngày hôm nay. So thank you very much for spending your time today with us at the training. So you can also rewatch the YouTube live video. If you have any further questions, please direct to Deepanshu@persistence.one. So once again, thank you very much for joining this session, and we hope to receive you in the next training sessions. Thank you and have a great night, or have a great day. Bye-bye.